Well, hi, good morning. Just before I get going on the radio here, I just wanted to show you something because today is November 11th, and that's Remembrance Day in Canada, where we turn our thoughts to those who've served in the military in the First World War primarily, but also Second World War and other things that Canadian citizens have done through their army. So I'm here on the Library and Archives website of the Canadian government. And we're going to do a collection search for my last name. There it is right there. And up comes this picture here. Maybe I can click that. There we go. So this picture was taken just after D-Day, a couple weeks after D-Day, and it's taken just outside of the city of Caen in France, where the Allies, the Canadian Army and the British Army in particular, were fighting against the German Army in the city of Caen. The city of Caen is a substantial city and a very important one because of roads and railroads going through it and whatnot. So these three men here are Canadian soldiers, and they're looking at a map of a minefield in the area. So this particular fella here is my father. He's about 19 there, maybe. Something like that. My father died a few years ago. He lived to be 91. And he had a good life after the war, but obviously was changed by his experiences in the war. He landed on D-Day. He landed on Juno Beach. He landed with the Queen's Own Rifles. And he was in the one of the first boats, very first boats. He was part of the shock troops to hit the shores and attack the shoreline defenses directly in order that the next wave can come through. And I always had this impression that when they landed on the shores, this is from Hollywood movies and things like that, that there was 100,000 soldiers hitting the shores. But no, when he landed, there was a total of 400 Canadians on that beach, and an awful lot of them suffered casualties. His particular group, the Queen's Own Rifles, had a 50% casualty rate, something like that, crossing the beach. It was really, really terrible, but obviously my father made it, and he continued to fight in Europe for about a year after this, before he returned home. So and then he became a teacher. Became a math teacher. So that was the father I knew, the math teacher. But I didn't know anything about his military history at all, except that he had been in the Second World War and he had landed on D-Day. But I never imagined he was among the very, very first soldiers to run across that beach. He never mentioned it. He just told me he couldn't remember anything of it. Right. Okay, so let's move on now. We'll go back to working on a radio. Okay, so today I'm hoping to work, or I plan to work, it's more than a hope, I plan to work on the audio circuits in the radio. And that's what I'm focusing the camera on, the audio area of the radio. And you can see the schematic up above, and if I hold this up, you can see that what I've drawn a map of the capacitors and numbered them in the radio, so I can quickly relate to what capacitor is what here on this diagram. I think it might be interesting to just take a look at some of these particular capacitors and see what's up with them. So one of them is this one right here. This is one that's been replaced by somebody previously. I'd like to know a little more about that. That's capacitor number 32. So we'll look on the diagram for C32. There it is right there. So C32, according to this, is a 0.01 capacitor. What it's doing is it's blocking the high voltage from the plate of this tube. High voltage coming in here. It's blocking it from getting onto the grid of this tube. Now I did not, when I was reading voltages, I didn't actually read this voltage here. Chances are the capacitor, this one that's been replaced, is good. And so there isn't any leakage. But if this were one of those older ones that you see, these kind here, they would almost certainly be leaking a small amount of charge through them onto this grid circuit. You can see this is a 500,000 ohm resistor here. So it wouldn't take much charge coming through to push the potential of this grid more positive. This is a positive voltage here. So that's almost certainly what has happened in this radio. It could even be the reason why the 6F6 tube is no longer in there. It may have wore the tube out because the grid went too positive. Positive grid causes current through the tube, even when there's no signal present. It causes excess current or unnecessary current going through the tube, heats everything up, wears out the cathode early. That's probably where this tube went. Now there's a 6 in there. So the thing about this capacitor in the radio, it's this nice shiny one here, is I don't know what the value is. It says 1.5K HP on it, and for the life of me, I don't know what that really means. So we're going to have to figure that out. The value is not terribly critical as long as it's not too small right in here, by my understanding. So now there's another one that's been changed, and this is the one that was hanging open earlier. That was this one here, and I put in this guy, and so that's 34. We look for 34. I look for, here's 34 up here. So 34 is between the plate and the cathode, and I can only guess what this is doing is it's trying to short out or draw off, or whatever the word you might want to use, any RF that's made it all the way through to here. The RF is supposed to get snuffed out way back here in some of these capacitors, but it's never 100%. There's always a little bit, and these are amplifiers, so a little bit gets amplified, and you could end up with some RF here. So I think that's the job of this capacitor. That's what I think, anyway. And so that one has been replaced, disconnected. Who knows what was going on with that? But it's in there now, and the radio works with it in. So that's 2 of them already done. Now I've got another one I've disconnected here to test it, discovering it has its own EMF inside it and whatnot. So it's really indicating it's in bad shape. This guy is number 31 on my little piece of paper here. 31. Where's 31? 29. Here's 31. So 31 is part of the tone control, and this tone control feeds back into, maybe that's an inappropriate term, is connected to a small resistor that's hooked up to a tab on the volume control. So the tab says 125,000 ohms. This is a 500,000 ohm resistor, so 125 would be what's 1/4? 1/4 of the way. If you turn the volume down, you're sliding this guy towards the ground here. So I think that pictorially they've shown it almost in the middle, but I think it's actually physically would be better pictured down here. Now what exactly these tabs do, I don't quite understand. They're used, it seems, in a number of ways in radios. I think generally speaking, I believe they're intended to boost the bass a little bit as you turn the volume rate down. So if we think about that, if we look over here, we see a capacitor, see its size relative to this, and that's not maybe an important comparison, but it's smaller. And you see the tone control just goes to ground here. So if you were to turn the tone control all the way up here, you'd be putting a ground on the other side of this capacitor, and anything that came through it wouldn't be going anywhere else, and whatever came through it's no longer available to continue on. What would come through it is the treble, the higher notes. This has to be sized correctly for this to work, I would imagine. There's another littler one here, permanently grounded, but see, it's much smaller. So this guy's trying to knock out any RF again, I'm pretty sure. That's his job. So change the volume control, you change how much treble you're throwing away from the signal in this wire. So let's suppose you've thrown away quite a bit of it. Okay, so you have muffled sound coming out of the speaker. You have the control turned way up here. But what is also coming through here is a bit of bass. How much? I don't know. I don't know. I mean, this you'd have to work out. You'd have to calculate that with this capacitance, this resistance. Things get a little complicated. There's another capacitor here. If this resistor, ground is down the way here, it's only a quarter, not like what it looks like. So I can never analyze these things to really sort out how they work or what they do. This part's easy, but this feedback into the volume control. Oh, I probably read about it at some point, but I can't remember it. So that's what that guy's all about. He's just about, what if this guy's completely out of the picture? Because I have cut one leg off down here. I just had it temporarily clipped. Well, that would completely hobble this tone control thing, and it would whatever's making it through this resistor would no longer be there. I don't know. I guess we could make and break the tone connection there and find out what it does. Find out a little more what it does. But then again, this capacitor is probably bad. This one's probably bad also. And so, really, what can we do? I'd have to replace these capacitors, and then I'm not going to bother experimenting once I've done that. But I do have a clip lead here, so it would be pretty easy to just go like that, see what happens. Is there anything else really of interest here? So the capacitor up here, 24, that's up here. Is that part of the audio circuits? Let's see. Well, here it is, right here. 24. No, it's this is part of the IF system. The IF amplifiers here. So 24 is not in the picture. And what about 22? 22 is this one here. We look for 22. 26. 22. Way over here. Did I get that right? 22. It's hooked up directly to one of the pins on this first IF. And, yeah, you know what? There it is. That's the IF, and there he is going over to one of the pins. So, is that part of the audio picture? No. No, it's not. So, better just... So these two, not to be changed yet. Just want to do the audio ones. So why don't we take a look at what this guy is. This is number 29. Yeah, there's just look for it. Yeah, there it is. So 29 is very important. 29 is a fairly small capacitor carrying all the audio kind of from the radio detector onward to the preamp in here and then off to the speaker. If this guy's weak, everything is weak from there. If it's leaky, that could present a problem too, I think. Because there's a DC voltage building here. And I'm pretty sure this is just going to a switch down here. Whoops. Oh, some of this may not have been on the screen. Uh-oh. Well, I apologize if I had this off screen a little bit while I was talking. So, well, I lost track of where I was. How do you like that? Can't be very important. I'm kind of, it's this guy here. So yeah, so he needs to be done for sure. So that's number 29. going to call it the audio, even though they're all audio. But now that's carrying the audio right through it. So let's just look at the critical capacitors. And so the signal's going through here, and coming out the plate, going through here. This one's been changed. All the rest are kind of beating the signal a little bit here and there, doing things to it, but not actually passing it through. Just those two. So that'd be a good one to start with. See what happens with that. The grid here looks like it's kind of a grid leak biasing deal here. So I would guess if this capacitor is leaky, that would interfere with the bias here. I don't know. Okay, time to start changing some capacitors. Well, let's start. I think what I'm going to set up some way of analyzing the quality of the sound in the radio right now. We'll experiment a bit with this clip lead and the tone control a little bit. And then we'll change the capacitor that's carrying the audio. Let's see if that does anything. And we'll just selectively change the rest, maybe without too much selection. Hey, what about this one? Number 30 here. We didn't really look at that. Number 30. Number 30. Number 30. 29. 28. 31. Where's 30? 30, here it is. Oh, so 30. 30 is this guy. We'll do this guy first, check and see what happens. Then we can do these ones in the tone control next, see what happens. And then what? Then whatever's left, and see what happens then. That sounds like a plan. I like that. Okay. So I think the very first thing I want to do is I want to send an audio signal into the phono input, switch the set to phono, see if sound comes out the speaker, because it didn't last time. But subsequent to trying it last time, I found out there was no B plus on the audio preamp tube. Now there is. Let's try this again. Okay, so I'm just plugging it into the phono input. Okay, this capacitor is connected via the clip lead here. Volume down. Tone about middle, so the volume switch is on. Just going to leave this connection here. This is going into the IF. I don't think it matters because we're going to be switched to push button. But first we're going to start with it on the A band, the broadcast band, just to make sure everything is working as much as I can reasonably expect. Let's just simplify the bench here a little bit. Okay. Okay, radio is running with 103 volts. Very, very low volume here. That's an observation in itself. Okay, are we really listening to the radio? Yep. Okay, now, just for interest's sake, what happens if I disconnect that? That's interesting. So this kind of sound, probably not dirt in the control, probably DC going through it. And we already know from looking at capacitors what could, well, this one right here could do it. Okay, turn down the volume just in case we get a surprise. It sounds about the same. Noise is gone. So I mean that just demonstrates, probably demonstrates that that's leaking DC through the tone control. Not a good thing. Maybe we should leave it disconnected. Okay, we'll switch now to audio. Input, phono input. Still hear nothing. Okay, but the input's very low. Okay, we'll raise it up. What frequency are we at? I think we're at 2 kilohertz here, 2000 hertz. Pretty sure that's what that is. Not a thing. Makes me wonder, do I need to prove what else could we be at? Let me do this. No question, that's almost 5 kilohertz. We don't hear a thing. And the levels are all up, full. Nothing coming out. Why would that be? Something up with the switch. Something. So I would really like to solve this before we go any further. Why no audio coming out? Some chance there's no audio coming out of my signal generator, and I just somehow fooled myself here. That's possible. The plug may not be making contact. Let me just take this off here. So the tone control is disabled now. Yeah. Okay, so it's plugged in here, where it's supposed to be plugged in. Just can't quite turn that. So I should turn the volume down and then turn it up a little bit. This guy's going full tilt, the signal generator. Why nothing there? Just silent. Something more to this that I'm not cluing into. Maybe there's no signal coming from the signal generator. Let's see if we can double check that situation here. Okay, just grab a speaker. Hook up the output of that signal generator right to the speaker here and see what we hear. Okay, so we'll level down, disconnect here. It's just possible the radio is looking for a very strong input at this point where I'm trying to inject this, and my signal generator doesn't have much oomph to it. That guy there. I hear nothing. Oh. Some DC coming out of this guy here. This has a DC offset control, but I was pretty sure there's a problem. But I don't hear anything. I don't hear any tone. No tone. What's going on? Why is that the case? I once again fooled by my own equipment here. Okay, I'm going to stop for a bit. Ponder this. Well, this is the output from that signal generator. If I turn down the frequency, radio my scope does not like to trigger here, so I'm just going to cheat and kind of steady it up like this. So nothing wrong with that. 5 volts per division, and it's, there's 10, 12 volts there. That's lots. Let me just check the padding, yeah, and the vernier, yeah. So it seems like there's lots of signal here, and we should be hearing that in the speaker. We certainly should be hearing that. Well, but we're not hearing it. What about the DC component? Let me flip this over to DC. I don't see any DC component there. If there is, it's tiny. Just for interest's sake, let me turn on the offset. And there you can see I can offset this. 0 is about there, according to this. Yeah, perfect. But the offset is turned off, so there's no DC there, so I don't know why that speaker was making the sound it was making. Something's going on with the set in terms of the phono input. This is a little bit important because the future of this set is probably to have a Bluetooth receiver plugged in there. Yeah. Well, I gotta think a little bit about how I want to do this. A bit of a logistics just on my bench. I gotta think about. Well, it's just taking me a moment to make another odd observation here. So this is on band A right now, which is the broadcast band. It turned up full. Remember, the antenna's not plugged in, so, and this terminal's not connected, so it's got no antenna on it. Barely hear it. Now I'll flip it to push button. What's with that? Oh, it sounds like a radio. Something. Oh, yeah. You know why it sounds like a radio? I hadn't pushed. I know what it is. I didn't push the audio button. Okay, mystery all solved here. It sounds like a radio because it is a radio. But if I push this button, we'll be in business on all fronts. Let me turn this output down before I get into some kind of disaster. Okay, push the button. Push the button. Right, push the button. Okay. Nothing there. Now we'll make sure we got the audio signal hooked up here. So this is the input to the radio. So all that just to realize I have to push a push button. Well, okay. I hear it. There we are. Excellent. You can see the lower trace is the one we're listening to now. Upper trace out of there. So let's just, we're listening to it right on the speaker, so unfortunately volume's got to go high here. I would like to drive this to the point of seeing some kind of distortion. So I'm going to turn down the microphone level in the shop and do that. Okay, so what I was doing there was I was turning down the volume on the radio as I was turning up the input signal. The input signal is running full blast, so that was about 15 volts, was it? And I see no distortion in there. Looks really nice. Let's go up in frequency. That's as much a test of my speakers as it is anything. Let's go down. There's a little something happening here. Some kind of a little bump. It's really hard to see on there. You can see there's a little bump of some sort. Well, now you can really see it. That's the volume control doing that. Now I'm going to turn up the volume control and turn down the input level. The volume control up high, this bump shows up. But I get the same level here by turning down the volume and up the input. We'll get the same size here. What happened? Looks exactly the same. Let me try this again. Down on the input, up on the volume. Looks exactly the same. It's very curious to me. What this noise at the bottom here that we can't really hear right now. Up the input level. All kinds of weird stuff showing up. What's doing that? Let's really give her here. I'm going to turn down my mic level here. Well, I don't have that capacitor connected. Let's connect that front capacitor with the clip lead here. Let's see what happens. Tone control. Okay, with the capacitor connected, volume up full. Tone control. Doesn't do much. Volume. Signal up high. Tone capacitor disconnected. It's all pretty interesting, but I don't know what to make of much of it. I don't know. By disconnecting this capacitor, we're disconnecting that entire feedback path, are we not? Into the volume control. So that says that's not part of it. Well, I think we change out a few tired capacitors here, and maybe that distortion in the bass will disappear. And what frequency was that happening at? I mean, we can hear it quite clearly, so it's like around 100 or 100, maybe higher, maybe even higher. 88 hertz. I don't think so. We can't hear 88 hertz. Maybe what's going on here is this is the 88 hertz. This bigger wave here. Oh, do that. So maybe this bigger wave is the 88. When we turn it up, these whatever they are, harmonics or jumpy things they are, I don't know what to make of that. tune the radio. No. You never know what might happen. And the tone. You can certainly hear the highs come and go. What little there is. The hiss. Okay. All curious stuff. So basically, I think what this says to me is at the high end, the receiver is reproducing the input just fine at the high frequency end. The low frequency end, something is happening, and it's producing a harmonic or something, which we can hear quite clearly, but doesn't actually represent the frequency that's being presented to the radio. So this would be the muddy bass, or some term like that maybe applied to it. So we'll change a few capacitors, and we'll see if some of this doesn't clear up. Okay, I've got one capacitor replaced, and I'm curious about this one that somebody else put in, what the value is of it. So let's take a look here. 5,000, almost 6,000 picofarads. So that's 5,000.005. That's what that would be. Well, it's supposed to be a 0.01. So I think I'm going to put the correct size in there, because this is carrying the audio signal through it to the grid of the output tube, and I think having the correct size of capacitors there is probably fairly important. So I'm going to change that one with the 0.01. I think it's a good idea to give this capacitor a test here. This is the one that was right off the volume control and conveys the audio signal to the first amplifier grid. So I'm going to stick some voltage on here and see if anything leaks through it. Okay, so keep your eye on the pi there, which is a little hard to see. Yeah, it's a little tough in here. Not sure I can make it any more visible. Maybe a little bit there. So 50 volts, what do? Popped right open. That's hard to believe. 150 volts. Something not right here. Maybe I don't have a connection. Let's go back to 50. Okay, try again. Pop right open. 250, pop right open. Well, this capacitor is showing that it has no capacity at all. Like it's the lead is disconnected, because that just didn't seem right at all. Let's try it on this guy here. The volume is very, very weak in this set. What do you say? You say it's a 0.05. No V loss, no loss. Picofarad. No, that's not. That's picofarad. That's tiny. V loss 0. I mean, this just isn't possible as an old capacitor like that. So I think this is really showing that this thing has no capacitance. Probably because of a lead separation. I don't know. I think we're going to see a big difference now in the volume in the set. No reason to test this guy here. He's going to be okay. Just the wrong size. But I have the right size in there now. Okay, so we're going to hook back up the audio. Gotta get this dangerous stuff out of here. Okay. Volume down. Power on. There we go. Okay, so I think that sound is the voltmeter pointer shaking on my little voltmeter here. set not on? Oh, it's not plugged in. That's why it's doing that. Okay. Well, that's an interesting thing. You overdrive the meter hard enough and it becomes a buzzer. Let's try again. There we go. Okay, so I still have the same signal generator running with the same supposedly 80 signal going in it. And we're coming up around 100 volts again, a little low. Oh, does that ever sound different? Okay, let's take a look on the scope here and see what we can see. First we see a reflection of this light. Here we go. Oh, lovely. 80 hertz. Really? 90 hertz. Well, I guess that could be 90 we're hearing. It's coming out of some small speakers though, but the distortion is all gone. Completely gone from it. This is with the tone control connected. Let's just turn the tone control. Oh, okay, so looks like the we can still at high volumes it's still distorting. Let's try this is a very high signal input. Let me reduce the signal input, raise the voltage up, raise the volume up. So that's a volume up full and the input signal down low. You can really hear the you know what I'm talking about. Kind of adds a buzzy sound. Harmonics, it kind of adds a buzzy sound. That's treble up full. Let's see if we can go up in frequency and see if we can. Ouch, that hurt. It's a little loud in here. Okay, how small the signal is, but listen to how loud it is in here. Our question would be, if I can get just one wave on here. It's really a disaster that I can't get this guy to trigger. He just won't do it. Triggering on. Hey, there we go. Oh, that's not triggering. Bear with me a second here while I just. Well, so what can be seen here, certainly I can see it, is there's some kind of very high frequency. There's a low frequency. And there's a very, very high frequency in there. Now, this is probably what we're hearing. I've got the scope sweep pretty high. It's just, yeah, wow. It's really a drag when you can't freeze this. I'm going to have to work on this scope or switch scopes or something. Let's go down in frequency. Down, down. Okay, I'm going to fool with the tone control. Oh my gosh. Yeah. Okay, the volume is up full, so I'm going to turn the volume down, crank up the input signal. So just where the sound begins to get sharp, the wave is no longer a nice sine wave. Right in there. Okay, some harmonic distortion, of course. How high is that signal level compared to what the radio itself does? I don't know. So where'd we get to here? We've done 2 capacitors and seen a improvement in the bass response, and I still have a lousy capacitor in the tone control. Why don't we get rid of that lousy capacitor in the tone control? There's actually two of them. There's one here, and then another one kind of grounding out the volume control tab at the back. Two of them. Okay, that's two more capacitors done. So a new one here and a new one right here. Yeah. Good. So here's the ones I took out. Let's check them out. Volts to start. This is C. Can't read what I wrote. 31. This is 31. Okay, 50 volts. Watching the eye. Pop right open again. Something funny going on here. Something's not right. Something is not right. Has it all lost their capacity? Is that what's happened? When you're doing the DC test, you apply a DC voltage. It takes a moment for the capacitor to rise up in voltage while the charge is rushing in. I expect to see that here. Don't expect to see that. What's going on? Dirt in the switch here. It's just popping wide open. Same here. I think it's a completely defective capacitor again. This was 31 and 31. 31. 30. .31 is the tone capacitor. Okay, and the other one is number 29. Oh, what did I do with it? Oh, for crying out loud. I've lost control. Control has finally left me. There's 30. Yeah, I have 30 written on this. So this is the one that's on the attached to the tab on the back of the volume control. Five. It's doing exactly the same thing. What's happening here? 250. Same thing. It's a little mysterious. Let me get out a good capacitor here. Give my capacitor checker a check. So what I'm expecting to see is the eye closes and then quickly opens again, but it has to close. What I'm seeing is it just pops open. Well, I get the same thing here. That's 250 volts on it too. Okay, this is charged up now. That's the problem. I've had it set on electrolytic. Okay, let's go back to 29, I think this was. 29, so this is the volume control capacitor. Now I have my machine set right. 50 volts. What do you do? Okay, now that's more normal. 150. it's not opening. So it's hard to see in the camera. Now everything's working the way I would expect it to be. As the radio works a bit, these things can't be totally shorted, they can't be totally open. That's not a very good one. 50, and it won't open the eye. If this were good, I should be able to put this all the way up to 450 volts, and that eye would pop right open again. That for sure is not going to happen here. So no surprise that these are all bad actors. Here we go. That's the worst of the bunch, I think, right there. Okay, that solves a bit of a mystery that was bothering me. Why are these capacitors testing the way they're testing? Because I had things set wrong. Okay, ready to test the radio. Now the tone control has been changed. Volume down. Double check. Everybody's soldered in. Nobody's shorted. Everybody's happy. Okay, that's good. Here we go. There we go. Oh, not plugged in again. There we go. My meter buzzer went off. Okay, we're running up around again 103 volts. Let's have a look at this. There he is. There's not nearly as much stuff in it anymore. Okay, so we'll turn the volume down, signal level way up. Lovely, lovely. There still is some very high frequency signal in there. I can see it with my eye. It's not obvious on the video. Okay, how about a little bit of tone controlling? And we're at 3 kilohertz here. Let's go way up. Okay, this is 5 kilohertz. Kind of a weird looking display. That's okay. Tone control. Way up. You can see the tone effect at 5 kilohertz. 5 kilohertz, that's plenty. That's plenty high for a radio like this. Let's go down. Okay, down further. Hot diggity dog. Losing control here. Okay, now signal down, volume up. Oh my gosh, so it's even with the signal rate down, it's picking it up. Looks like there's a bit of a hum in there. I can see this bouncing. I can see it bouncing a bit. That's 150 hertz. Okay, there's 75. There's 80 hertz. There we are. So you can see there's some other modulation in here. That's probably a 60 hertz hum. Okay, tone control effect. So there's no effect at this low frequency, which is what we would expect. And now, so the volume rate down, signal level up, volume up a bit. You can hear that in the speakers, but I don't know for sure that it isn't the speakers. This is pretty low stuff for those little speakers. Go a little lower. So I don't know how you can see this or not, but definitely the shape is not perfectly smooth in here. It's got some funny stuff going on. There we are. Okay, tone control up and down. Ooh. What's happening there? So I get the tone control right up so the highs are coming through and it kills the lows. It's kind of interesting. That's with the volume control. Oh. Wow. So this is a powerful signal coming in, the audio. I'm just turning the volume up. Wow. There's a lot of problems there. The question would be, so there's a nice sounding tone. Again, it kills it. The tone control set to what is it set to? So what's happening here is it's I don't know. doing some funny stuff though. Which way is treble up? So the treble would be turned up this way. Well, let's give it some treble. I'm going to turn this up. You like treble, do you? Yeah, that's definitely what's happening. So at the highest treble setting, it knocks out the bass. Is that really intentional? And then we've got this distortion, which you can hear. Well, that's interesting. I don't know what it is, but there it is anyway. Okay, let's just see. Where are we at now? Where are we at? Ooh. Okay, I don't know what's making all that noise. Could be the frame of the buttons that are hanging there were intermittently grounding onto the chassis. I'm not sure about that. Okay, where are we at? Where are we at? Where am I at? So we have this guy left. I got a cold joint, solid joint in there. Let's just see what's going on here. Somebody's not happy. Nobody's happy. think that's a cold solder joint there. Moving this is moving this connection here. Something almost shorting? No. Wow, it's really, really sensitive. Just a little resistor here. Wow, something is incredibly sensitive. Right here. I'm not sure what that is. Could be the tube. A little hard to get at here. Could be push from the bottom. Where did it all go? It must be the tube. Still working? Oh yeah. Okay, we'll assume that's nothing more than the tube pins in the tube socket doing all that nonsense, because all those solder joints look pretty good. I was pretty careful with them. Okay, so I think that's it for audio capacitors. The remaining ones are related to the IF section. That's for tomorrow. We'll fool around with that, and keep in mind that there's some weird thing that happens with the bass in this radio. Hey, what if I just give it, let's just check something here. I'm only running it on 100 volts. Let's check this out just before I give up. Okay, so what I'm going to do, I'm going to crank up the voltage on the radio to full 120 here. Thinking about what I'm doing, almost made a big mistake. There we go. Okay. Still has the same distortion. Okay. Boom. Well, that's it for today. That's enough monkeying around in here. Oh my gosh, look at the time. It's after lunch. Yikes. Well, thanks a lot for watching this overly involved video. But I am trying to wring out all the fun I can from here. He says, realizing I've had the volume down a little bit. Okay, we'll see you tomorrow.